Hi, in this video we are going to see about the fire tube boiler, water tube boiler is Babcock and Wilcox boiler. So we are seeing about boilers in this module. Boilers is the one which is going to be produce steam by applying of heat in the water. Okay, so it's now Babcock and Wilcox boiler. It's a horizontal drum axis and natural draft, natural circulation, multi-tubular. It's a stationary boiler and a fuel fire. We are putting fuel inside. Externally fired water tubed boiler. So in the earlier videos we have studied the fire tube boiler Lancashire, where the tube is the hot flue gases are passed through the tubes, and surrounding the tube water is present in a drum. So the water gets heated up, the hot flue gases, and the steam is getting produced. It is there in the Lancashire. But in the case of a fire tube water tube boiler, water is going through the tubes and fire is outside externally. It fires this water. So you can see the construction of this fire tube boiler, Babcock and Wilcox boiler. So you can see this drum with water, and that water, there are two important heads are there. One is intake and this uptake head, okay, downtake header. So the right side of this downtake header, you can say the water is coming downwards. The blue color indicates the water. The water comes downwards and it is filled in the pipes. Normally, you know that there is a heat difference when the hot and cold water is that get combined. Normally hot will move upward, okay, cold water will be at the bottom. This is what the logic how it is going to be taken place. So we can see here the water, once the water is getting filled in the drum, the water is getting down to the down take header, and it is filled in the tubes. The tubes are then at the bottom, coal is getting fired, the grate is there, we are putting the fuel and we are burning it. So the entire area is hot, very hot. Fuel flue gases are spreading. The hot flue gases will pass us through over the tubes. So when the hot flue gases passes over the tubes, the water inside the tubes are heated up. So, and there is a baffle plates which directs the flow of flue gas in a proper way. That is always it contact every tube, and it will goes to the chimney. So the at the right end top, you can see that chimney. So hot flue gases will pass through this and it will go to the chimney. So here the water is getting heated up and a steam is getting generated. The hot steam, it automatically moves upward in the tubes, and it is going to be get settled in the top of the boiler drum by using the uptake header. And there in the top of the drum there is a safety valves, and steam stop valve will be there. A manhole is also there. So the steam, when the steam is getting saved over on the top, then by using valves, it is steam stop valve is there, and other valves are pressure gauge will be there, water level indicator will be there. So these are all the things in the boiler, and this will help to bring the steam to the turbine by using the pipes, so that it will hit on the turbine and it rotates the turbine. So the various parts here we have to concentrate is on the drum where the water is getting filled up, it contains the water. Downtake header as the one where the rear end of the boiler, where it is connected to the water tube, and it receives the water from the drum. Like that, uptake is after getting the heat, the steam is getting heat, and then it goes to the boiler upward. So uptake header. And water tubes, or the tubes where water is flowing inside. So and what steam is circulating outside. So the baffle plates, or the plates where the water tubes which is present the water tubes, it allows the zigzag movement of the flue gas to have a much contact in these tubes, over the tubes. Next to fire door, there the coal is going to be fired over there. And the mud collector at the bottom of the downtake header, it is used to collect the mud settle at the from the water. And feed check valve, these are all the valves which is used to fill the water into the drum. So how much water we have to fill, to control the flow of water, some check valves is needed. So according to this generation of steam, water is to be filled up thoroughly. So normally the water comes through the down taker and gets heated up the hot flue gases. So these hot flue gases come from the contact with the water tubes and convert the water into the steam. This is what again we are saying this process working principle. The steam is generated upward and through the uptake header and settles in the top. So the dry steam enter into the superheater. After that, the dry steam which is settled on the top of the steam drum, it is enter into the superheater. The superheater receives the water-free stream from the anti-priming pipe. So it increases the temperature of steam to the desired level and transfer to the steam stop valve. So normally in the steam there's a wet condition. Already we have discussed wet steam, dry steam and superheated steam. So the wet stream, if it goes to the turbine, then the efficiency of the turbine will be less and the steam will be less. There's rotation of the turbine, and then the water particles continuously contact with the turbine. It makes corrode the turbine. So continuous water particles should be avoided. So in the steam itself, we are heating much, still we are heating the steam totally, the water particle in the steam should be avoided. So the wet steam is further heated up and it becomes dry steam, and the dry steam and again we are sending to the superheater where it is getting superheated stage where totally it's a gaseous stage of steam comes. So it will send it to the turbine, so that the turbine is used for the rotation of and the production of electricity. So here where the application is, where it is used in industries, mainly high pressure steam in the power generation industries, so to produce the electricity in thermal power station and all, we can see a high pressure steam is needed for the production of electricity. What is the disadvantages of this Babcock and Wilcox? So here it is not suitable for impure sedimentary water. Yeah, water should be purified, so we need some purification process. Otherwise water is the sedimentary water gets sedimented, the salt water gets sedimented inside the pipe. So a scale may deposit in the tubes, and it in future it can have a damage to the pipes. So water is also not flowing properly. These are all the things will come. So treatment is important, and the continuous supply of feed, water is required. Suppose what will happen if water is no shortage, then boiler gets overheated. So here the difference between fire tube and water tube is hot flue gases are inside the tube and water is outside in fire tube. Why in water tube, water is inside the tube and hot flue gases are outside, and it works. Fire tube works the limiter to 25 bar, but water tubes work more than the 25 bar. So that the fire tube is not suitable for larger pressure, but water tube is used for the larger power plants. Okay, and high pressure, the change of explosion, the chance of explosion is less in fire tube boiler, because water is fully surrounded the pipe. Even if what happens, the water is getting the fire of the pressure what it is created, or the explosion is not much effective. And here in case if it comes, there is a less chance of effective explosion will be there. But in water tube there is high pressure. Due to high pressure, water tube boiler having more chances. Next, producing process requires less skill, efficient, economic worker. Here, more skilled people are needed, and there is no problem of scale deposition. Very important point is the fire tube boiler. There is no deposition of scale because water is filled in the entire drum. But here in water tube, the pipes, the water is going through the small pipes, so there is a possibility of settlement of this scale over there in the tubes in over periods. So this is one important drawback in this water tube boiler. Next we will see the remaining thing on the boilers, mountings and accessories.